it's actually etched into the silicon using deep reactive ion etch technique, which allows us to create very sharp sidewalls. Okay, and so we have essentially the acceleration jet here, the major flow and the minor flow, and then this has been designed such that the larger particles, the particles above the 2.5 micron cut point, are expelled into the minor flow, and then the particles that are smaller are actually making the turn and then they're continuing this way. So this is your virtual impactor, this is the minor flow channel. We have the bigger particles continuing this way and actually going out to the outlet, whereas the small particles are actually making the turn here and here, okay? All right, further down on this flow path, right? So now we have size separation, okay, that's done through virtual impaction. The particles continue this way. This is now PM 2.5. And then half of these particles reach this area here, which is where the thermal precipitation happens. And so this is, again, a zoom-in view on that area. And you can actually see all three wafers in this micrograph. So we're looking again through the top quartz wafer. You can see the heaters here, okay? This is on the top. They're suspended above the resonator, which is here, all right? And then this is the driving circuitry. This is actually inserted through the bottom of this middle wafer here, which you can actually see here, which defines the channel, all right? That heater is suspended about 100 micrometers above the resonator and creates a very strong thermal gradient from the top to the bottom, so from the heater to this resonator. And that gradient pushes, essentially, these particles out of the airflow, okay? And you can actually see it after we disassemble this device. You can see here this is the resonator, and this